Hello, let's do the New York Times Medium Sudoku for May 11th, 2024. There's a link in the description if you'd like to try the puzzle yourself in the same software I do, which I find nicer than the New York Times built-in solver. And I'm going to get started right now. Okay, so we take a systematic approach to these solves with the idea of explaining everything as I go, as if you've never seen these techniques before, and also explaining why we go about the solve in this way. So I'm teaching a very specific technique here that I find more enjoyable than what you may already be doing, and also is pretty efficient. So let's get started. I do want to go over some terminology first, just so we're all on the same page. I call these cells, and these are fairly standard terminology, although you will find alternative words. But these are cells, so each individual, there's 81 of them in the grid. It's a 9x9 grid of cells. So a cell is what will receive a digit. By the end of the puzzle, every cell will have one digit in it, exactly one, not 0, not 2. All right. We also have rows. A row is a horizontal line of 9 cells, and we have a column, which is a vertical line of 9 cells. And then we have a box, which is a 3x3 box of cells that is bold outlined. So there's 9 of those in the grid. This wouldn't count, right? Even though this is a 3x3 of cells, it's not a box because it's not bold outlined. And so, of course, the Sudoku rules are that in every row, every column, and every box, we have the digits 1 to 9 exactly once each, which means we can't repeat any digits, and each cell is going to have one of the digits from 1 to 9. And if we counted, we would count for every digit within every row, column, and box. Now, every Sudoku has only one solution, which means guessing is very bad, because if you guess, every single time you guess, you run the risk of filling in the wrong digit, because there is only one correct digit for every cell. And we can logically figure that out, and that's much more interesting than guessing anyway. All right, so what is our strategy? Well, another piece of terminology I want to talk about is a band. It's just a convenient way of talking about a row of 3 boxes. So there's 3 bands in the puzzle. And what can we say about every band? Well, every band, because it's made up of 3 rows, it's also made up of 3 boxes, pick one, it's going to end up with 3 of each digit. Just like a row has 1 of each digit, 3 rows will have 3 of each digit. And so what we want to try to do is try to find where there's 2 of a digit within a band, and that significantly restricts where the third one can be. Now, there isn't an example of that in this band, and actually there's nothing that we can do in this band that I can tell. So we're actually going to move on. We're going to start with this band here. So in this band, first thing we want to do is look for where a digit appears exactly twice. So the way that I do that, and I think it's a pretty efficient way, is to compare each box against each other box. That's 3 comparisons in total. So I start with the box with the fewest givens in it, because it's easiest to remember which digits are in there. So we have the 2 and the 7. And I'm looking in this box and this box for a 2 or a 7. And I find the 2. That means we have 2 2s in this band. And so where does the third 2 need to be? Well, it needs to be in the row that they're not in, and it needs to be in the box that they're not in. So it needs to be in both. So it's going to end up in one of 3 cells. Now, of course, you can tell it's not this one, but we're not worried about that right now. Another way we can prove that it ends up in one of these 3 cells is that this 2, because we can't repeat the 2 in the row, it does not appear in these 3 cells, and this 2 does not appear in these 3 cells. And so this box needs a 2, and it's not in these 6 cells. So it's up here in these 3. So however you want to prove that, you can. You can also prove it via the row. I'll leave that up to you. No need to repeat this third time. Anyway, so we know that one of these 2 cells is going to end up a 2, so that the box gets a 2. So we can't place the 2. We're not going to guess. But we do want to remember that the 2 is going to end up in one of those 2 cells. And I recommend using corner marks for that. So corner mark mode, so this Sudoku pad software has corner mark mode and center mark mode. In corner mark mode, when we place the 2s, they end up in the corner. And what that's going to signify is that within the box, this is the list of cells that can be 2. And that's just what it's going to mean, just by our own convention. All right, so we have notated that. We remember that. Are there any other repeated digits? Well, the 7 doesn't have a repeated digit. We need to compare these 2 boxes against each other next. The 1, 2, and 8. There is no 1, 2, 8 over here. So we're done with our comparisons. That's all the duplicated digits. Now, before we move on, 2 things I want you to look for. First thing is if we have a completely filled box row, which we do not. A box row being just a row within a box, right? And so none of them are completely filled. And the other thing we want to look for is a row or a box down to 4 or fewer open cells. I don't see any of those either. So we're just going to move on to the next band. Let's start with this 5, 8. It's the fewest box with the fewest givens. So we look for a 5, we don't see one. We look for 8, I do see one. So we have these two 8s, they look into this box. And so 8 ends up in one of these two cells. All right, now we can look for 2, 6, and 7. I do see the 6, these 6s look in. If this 6 looks down, we can put a 6 in one of these two. Now that's all the repeats. Notice I only had to do a few comparisons. This 5, 8 against these two, and then this 2, 6, 7 against this one. That's all I had to do. Very, very fast if you don't sit here and explain it. And so then the next thing you need to do is look for build box rows. There are none of those. That's very easy to see. And we're looking for any rows or boxes down to 4 or fewer. None of those either. Okay, so we're done with the 3 bands. Now this is a stack. A stack is just kind of a rotated band, right? It's a column of 3 boxes. We're going to do the exact same thing to the stacks. It's just anytime I said row, say column instead. So we'll start with this 3, 8. We do have the 8 repeated. These 8s look in here. So 8's in one of these two cells. And then there's not a 3. So now we just do the 2, 7 against this box. We do have the 2. The 2 looks up. There's a 2 in one of these 3 cells. And we don't have anything else. Any filled box columns? No. Any columns or boxes down to 4 or fewer? No. Okay, so we're going to move on to this stack. We're not finding a whole lot on this first pass, but that's okay. We'll find something else. Or maybe these stacks will be helpful. We'll find out. So I'm going to start with this 1, 5, 9. We do have 2 1s that look down. These two can't be 1. So now we have our first hidden single. A hidden single. The hidden means that we're dealing with a row, column, or box. So really I should say it's a hidden single in the box to specify that we're hidden within this box. So within this box, there is a single hidden in it, right? We have to look at the whole box. And we have to say which of these cells can be 1. And the answer is only this cell. This single cell can be 1. So it's a hidden single 1 in box 8. And so the result is we can place this 1, because if we don't place the 1 here, we won't be able to place the 1 anywhere, and that breaks Sudoku rules. So we must place the 1 there. So we can confidently place our first digit, this 1. Okay, so that was the 1. Now the first thing we want to do when we place this digit is we have already scanned this band, but now we have updated information. We place this 1. So we want to check to see if there's any buddies for the 1. There aren't any. We want to check if we caused the row or the box to be 4 or fewer cells. We did not. So that's fine. That was the 1. Anybody for the 5 or 9? There is not. Okay, down here we can look at the 2 and the 8. So we do have the 2 2s looking up. That puts a 2 in one of these two cells. And that's it. That's it for repeats. So the next thing we look for is a filled box column. We actually have this filled now because we filled the 1. So when we find that, we want to scan these 2 columns in the box that this isn't in. So it's the 2 columns it's not in and the 2 boxes it's not in. And we want to look for any digits that aren't yet placed in the box. So we don't care about empty cells. The 1 and the 2 are already placed in the box. And that leaves the 9. So you can see what the 9 does to this box. It takes it out of these 3 cells. And these 3 are also not 9 because they're filled with non-9s. In addition to that, this 9 looks in. And that lets us place the 9 in the box. We have a hidden single 9 in the box. Now, before you place a digit into a cell that has corner marks in it, pay attention to what digits those are. In this case, it's the 8. Now, if you do forget, Sudoku Pad is very nice. You can delete the 9 and the 8's still there. But if you remember that 8, now what you want to do is you want to look for where all the other 8 corner marks are in the box. And that's here. There's just one of them. So the 8 is also a hidden single in the box, just based on the fact that the corner marks is a list of all the cells that can be 8. And there is only one cell, one corner mark left. So that can just be upgraded to an 8 there. Now we place the 9 and the 8. So we want to follow up on those as well. Let's start with the 8. We have all 3 of them. That's fine. And we can do the 9. These 2 9s look in. This 9 looks down. Now we corner mark 9s here. Now this is another thing I want you to trigger in your head, that we have overlapping corner marks here. They're not just overlapping. They're completely overlapping. They're exactly the same cells. So it is 2 digits corner marked in the same exact 2 cells and no other cells. And it's the same 2 cells. So it's 2 cells, 2 digits in 2 cells. So what do these corner marks actually mean, right? They mean that the 6 is going to end up in one of these 2 cells, and the 9 is going to end up in one of these 2 cells. Well, they can't be in the same cell as each other, so they have to share those two cells. And when they do so, there won't be any cells left for any other digit. So we're either going to end up with a 6 here, which puts a 9 here, or we're going to end up with a 9 here, which puts a 6 there. Those are our 2 options. And so actually, these cells can only be 6, 9, and that's called a hidden pair. Remember, hidden means we're dealing with, in this case, a whole box. We looked in the whole box and we found a pair within it, a pair of cells that were limited to the same 2 digits. So now we can use center marks for this. We haven't done center marks yet. But what center marks mean is that this individual cell, this is the list of digits that are still remaining that could go in that cell. So in this case, it's 6 and 9 are the only 2 digits that could go in this cell. So we don't need the corner marks anymore because this gives us this 6-9 pair that's just visible through the center marks. Okay, so there's more to follow up on here because we filled this box row as well. We want to look here for anything that's not placed in the box. The 9 is, the 2 is, the 8 is, the 8 is, 6 and 9 are. So we don't find anything, but that's something we want to look for sure. And then we want to look to see if we've reduced any rows or boxes down to 4 or fewer. Well, this box is down to 3 digits, so we can look at that. The 3 digits are 3, 4, and 5. So I'm just going to center mark 3, 4, 5 here to remind us that that's what's left in those cells. Nothing else is kind of restricting that though. Now this row is also down to 3. And you might say, what about these 2 cells? Well, I know these 2 cells are going to be the 6 and 9. So we can't have another 6 and 9 in the row. So these are actually down to just 3, 4, 5 as well. Now this cell can't be 5, so it's only 3, 4. And this cell can't be 3, so it's only 4, 5. Okay, any other row or box down to 4 or fewer? Well, yes, this box is down to 5. This row is down to 4 digits. So let's think about what these are. They are the 1, 3, 7. I missed something. 1, 3, 4, and 7. Now, one thing that I'll tell you is it's not really good to be center marking 4 or more digits in a cell. It's just clutter, and it's not going to really help you find much of anything. And so I recommend only center marking the cells that are down to 3 or fewer. So we were down to 1, 3, 4, 7. So this cell sees a 3, so it's down to 1, 4, 7. So that's okay to mark. But this is down to all of 1, 3, 4, 7. So we don't really want to mark that. We'll leave that empty. Keeps things from being too cluttered. And you can also choose it if you want to not even do the ones with 3. I recommend building an instinct for what's going to be useful before you make that decision. And I would start by just doing all of them that you find. This is down to 1, 3, 7, and this is also 1, 3, 4, 7, so we don't mark that. Now, something I noticed while I was thinking about this box is that all of the, like 1, 3, 4, 7, that's only 4 digits. And I'm noticing I haven't accounted for one of the digits. And in this case, it's the 2. And so actually I noticed that we have these 2 2s that I somehow missed the entire time, so we can corner mark those 2s. I don't know why I missed that. Maybe I got ahead of myself with comparisons, or I think I got the 6 and then I got the 9, 6, 9. I don't know. I think I just missed the 2. That's all right. It's there now. All right, so we have the 2s there. I don't think that's would have been super useful up till now. Actually, it is useful. So let me show you what I just found here. So this is one of the hardest things to spot, but if you do, it's very, very useful. So when I placed these corner mark 2s, I noticed that they matched up with these 2s. By matched up, I mean it's the same columns. So like these 2s don't match up with these 2s because these 2s are in 3 columns or 3 rows, and these are in 2 rows, right? This is in 2 rows, this is in 2 rows. It's the 2 rows we care about. If it's in 3 rows, don't worry about it. And it's the same 2 rows. So what does that mean? Well, in this box, the 2 is limited to these 2 rows. And in this box, the 2 is limited to these columns. These 2 columns and these 2 columns. I was saying rows over here, and then I got confused. Anyway, I was meant to say columns. So in this box, these 2 columns. In this box, these 2 columns. So the question you should be asking yourself is, where's the 2 in this column? Right? It's not in this box, and it's not in this box. So the 2 in this column has to be in this box. We can actually corner mark the 2s there, and this is called claiming. This is a very convenient way to find claiming, but you can also find it just by analyzing the column. Right? We can analyze the column and say, well, this isn't 2 because of this 2. This isn't 2 because of this 2. And this isn't 2 because of this 2. This isn't 2 because of that 2. Right? So when we find that 2 in this column is limited to these 2 cells. And these 2 cells happen to both be in the same box. Which means wherever the 2 ends up in this column, it will also be the 2 for this box, which means the rest of the box can't be 2. So we end up with 2's limited here, and these are not 2. And that's very important to remember. That's what the corner marks are going to try to help us remember. Okay, so that was the follow-up on all this stuff. We got the 8, 9, and all that. We still have this column to finish. The stack to finish. We were on that. That was this filled box column. We got the 8 and the 9, so we do want to follow up vertically as well. These 8s look into this box, placing the 8. Now follow up on this 8. And we can put an 8 in one of these two cells. And then we can also follow up on the 9. These two 9s look in. And this 9 looks in, placing this 9. Follow up on the 9. These 9s look in, placing this 9. Follow up on this 9 vertically. These 9s look in. So does this 9. That puts a 9 in one of these two cells. Now, this is not a hidden pair because the 2 can also be here, right? They need to be exactly overlapping and in no other cells. So the 2, because we are not actually required to put a 2 in these two cells because it could end up here, right? So be careful with that. All right, so we got all those 2s. So I placed this 9. Sorry, I got the 9. This got filled, right? So we want to look here to see the consequences. We do have this 1 looking in. So the 1 ends up in one of these 3 cells. Now this is going to do something called pointing. Pointing is very similar to the claiming I just talked about, but it's kind of the reverse. So in this box, the 1 was limited to these 3 cells. All 3 of those cells are in the same row. So they're going to be the 1 for the row as well, meaning the rest of the row cannot be 1. It's called pointing because if you kind of line up, if you sort of draw a line between these cells that can be 1, they all are in the same row, and you can continue that. You can point at the rest of the row, make an arrow out of it, point at the rest of the row and say, no, you're not 1. So that's why it's called pointing. So importantly, these aren't 1s, and this one looks and saying these aren't 1s. So the 1 in this box actually is one of these 2 only. Anything else looking in? So the 5 as well. So we end up with a 5 here, and the 5s point into here. This 5 looks in. End up with a 5 of one of these 2 cells. Now you will notice that the 5s do line up here, but we already have the 5 in this column, so that's not as useful. And we're still following up on stuff. Remember that. We're following up on this 9 here. So this got filled. We got the 1 and the 5. The 2 and the 9 aren't helpful. Cool. So this row is down to 4. So we can look at that. Just think about it. We need the 1, 3, 4, and 5. I'm seeing this cell can't be 4 or 5. So this is 1, 3. This is 1, 3, 4 because it can't be 5. These can't be 1. So these are 3, 4, 5. Okay. Get a drink for a second. Now, whenever you center mark a cell, you always want to be scanning the row, column, and box to see if you have buddies. And in this case, I noticed when I scanned the column that we actually made a naked triple. So let me explain the naked triple here. This can be one of the harder things to understand when you're first learning Sudoku. So this cell, if we just look at this cell, we just zero in on it, and we look at the center marks. In the final solution, what can this cell be? Well, we have it marked. It's going to be a 3, a 4, or a 5. We don't know which, but it will be one of those 3 and only one of those 3. How about this cell? Also 3, 4, 5. How about this cell? Also 3, 4, 5. Now, the important question to ask is, can I repeat any digit in these 3 cells? And the answer is no, because they're all in the same column. Because they're all in the same column, I am not allowed to reuse the 3, reuse the 4, or reuse the 5. So if 3, 4, and 5 are what these 3 cells are going to end up as, all 3 of those will get used because I can't repeat any. There are 3 cells and only 3 digits, so those 3 digits are what are going to end up in those 3 cells. And that means that the rest of the column, no matter how these resolve, cannot be 3, 4, 5. They just simply can't be. Let's try to place a 3 up here, right? If I try to place a 3 here, 3 is removed from all 3 of these cells. And now I only have 4 and 5 available for 3 cells. How am I going to put a digit in all 3 cells using only 4s and 5s? Right? I could put a 4 here, I could put a 5 here. And now this has nothing left to place in it. I'd have to repeat the 4 or 5 or the 3, right? It's not going to work. That's the point. So if the rest of the column can't be 3, 4, 5, what can it be? Well, it's the digits that remain for the column. It's the 2, 6, and 7. So I'm going to center mark 2, 6, 7 here, and this one can't be 2. Okay, and of course, when I place those, I am scanning around to see if I see anything matching, right? We don't care about, we placed it via the column, right? But we want to look at the row and the box. Okay, so trying to remember what we were following up on, right? We did these, we've penciled these 4, that gave us this triple, that made us pencil these. And so now, I noticed something. I was thinking about this 3, 4, 5 and how it removed 4 from these 3 cells. Well, I noticed that this 4 also looks in. And so now we have a hidden single 4 in this box. There's only one cell that can be 4, so that is the cell that is 4. Now those 4s do match up. Remember, I'm just following up on what we found. We put the 4s over here. Okay. We were still doing this vertical. Let's get back to that now, I think. This column is down to 2 digits. We have the 1, 2. We need a 3 and a 7. It does not look resolved to me, so I'm just going to put 3, 7 in there. This column is down to 2, 3, 4. No, not 2. Oh, 3, 4, 5, 6. This cell's not 5, so it's 3, 4, 6. This one's not 4, so it's or 5, so it's 3, 6 only. So I'm noticing in this box, the 3 is only in one of these 2 cells. Because these can't be 3 because of the 3, 4, 5 triple. It's the same thing that removed the 4. So since these can't be 3, the 3 ends up in one of these 2 cells. And I just noticed that by center marking. We could have also noticed it from what the consequence of the 3, 4, 5 triple. But these 3s point. They point into this box. These can't be 3. These can't be 3. So 3 ends up down here somewhere. Okay. Lots of useful stuff there. Okay, so that was that stack. Did I finish? I think I finished following up on this band. So we're going to do this stack now. I'm going to start with this 4. It doesn't have a buddy, right? I'm going to look at this 5, 8. The 5 has a buddy. It looks up into here. This 5 looks in. We end up with the 5 on one of these 2. The 8 doesn't have a buddy. So that was all the buddies. No filled box column. No column or box down to 4 or fewer. So I think we have finished our scan, our initial scan here. And we have not finished the puzzle. So what we want to look for are things that might be a bit more subtle going on. So we're going to go box by box, and we're going to look to see how things are restricted within that box, especially paying attention to how digits from outside the box are looking in. And we're not going to, previously we focused just on bands and on stacks. We're going to look at both the band and the stack together and how it affects the singular box. So one thing that I can notice is that we have the 3, 8 kind of staggered like this. And so there's a single row and there's a single column that they don't occupy. If we can find a repeated digit between those 2, then we know it has a really nice effect on the box. I don't see any though. The 8 is repeated, but it's already in the box. We don't care about that. But the 6 and 7 and 5 aren't repeated. So we don't find that, but that's what we're scanning for. The other thing I'm noticing is that there are 2 cells in this box that are avoiding a bunch of corner marks. In this case, the 2, 4, and 9. So if these cells, we know these cells aren't 2, 4, 9 based on the corner marks, and they're also not 3, 8. So that is 5 digits that they can still be. Or sorry, that's 5 digits that they aren't. So it's 4 digits that they can still be. But if we think about it, we might be able to find, for example, this 1 looking at this. So let's think about what those digits are. We can be the 1, 5, 6, 7. And so since this cell can't be 1, it is down to 5, 6, 7. And you can see the benefit. If we weren't marking cells that were down to 3, we would not have found this triple. So very useful still to mark 3. Okay, and then this one's down to 5, what was it? 1, 5, 6, 7. So we're not going to mark that. And I think that's all we get out of that box. Now, this box we already know everything about. We have it filled up, so we can move on. This box just has the 4 placed, but we also have the 2, 3, 5, and 8 as corner marks, which means this cell's not 2, 3, 5, 8. So what can it be? It could be 1, 2, 3. It can't be 4, 5, 6. I'm sorry, it can't be 3 because there's 3s down here. We need to pay attention to, and it can't be 2. Sorry. We need to pay attention to our corner marks in the box. So it can be 1. It can't be 2 or 3. It can't be 4, 5, or 6. It could be 7, but it can't be 8 or 9. So it is actually down to 1, 7 only. And it's because we have these 2s and 3s corner marked in here to remind us of some non-trivial stuff that we found about the box. Okay. Now something I'm noticing is that this cell does see a 1. And so even though it can be a 2, it can't be any of these other corner marks, and it also can't be the 1. So it is probably down to 2, 7, but let's see. It's not a 1, it could be 2. Oh, but it doesn't see some of these digits. Anyway, it can be 2, it can't be 3. It can't be 4 or 5. I think it could be 6 though, and it could be 7, but it can't be 8 or 9. Okay, so it is down to 2, 6, 7. Not as good as I hoped, but that's why we double check. Okay, so I think that's what I'm going to get out of that box. I'm not really interested in doing more. So we're going to move on to this box now. We're double checking because this is filled. We're double checking these to make sure we didn't miss anything. We're also checking to see if there's really anything we find would be related to these digits, and that we don't care about the 9 or the 2. So it would be just the 1, 5. We have that marked already, so we can just move on. Here we've got the 1, 2, 8, 9. So I'm mostly interested in how things look in, but we already have this box completely marked up. So really, I'm just going to take a little shortcut here, and I'm just going to think about each digit. The 3 can be in a bunch of places. The 4 can be in 3 places. The 5, we already have corner marked. It's there. The 6, we can corner mark in one of these two. So let's corner mark that 6 there. And then the 7 is in one of these two. We can corner mark that. Now that's new information that I hadn't noticed, which is that the 7 is only in one of these two cells. We could have also seen that from this 7 looking in and this 7 looking in, and these aren't 7. But these 7s point into this box. This 7 looks in, and that corner marks a 7 in one of these two. Now, do you see what just happened? We had this earlier. We found a hidden pair. These two 7s overlap in two cells, so we can just mark that as 2, 7. Now what that did is it removed anything that other than 2, 7 from those cells. That leaves these 4 cells to be those digits. It's going to be the 1, 3, 4, and 8. And I'm seeing that 8 now can only be in one place in this box. This 8 looks in. This 2, 7 can't be 8 because they need to be 2, 7. That's what our hidden pair did. And then this 8 looks in and the 9's not an 8. So we can place the 8 in the box. That removes this 8 corner mark, placing the 8 in this box. We have all our 8s vertically here. In fact, our 8's almost done. Yeah, oh yeah, we have this 8 removed here. That places this 8, and that's the final 8 in the puzzle. Very nice. This is down to 1, 3, 4. It's not a 4. So actually 4 in this box, also because of this 2, 7, can only go here. And that also places the 1 in the box. Remember that we had these pointing 1s. I should have seen that this was a naked 3, to be honest. This is the 1, this is the 3 for the box, because we had it corner marked that way. This 3 resolves the 7 and the 6. These aren't 4, right? So 4 now ends up only here. This 7 resolves the 3 here, which gives us the 6 as well. That leaves a 2, 7 pair here. This is not a 4 anymore. We can get rid of these corner marks. I'm just going to clean up a little bit. This 3 looks in, removing this 3, but there's still 2 places for 3. So we just got a bunch of stuff. So we want to think about what's the low-hanging fruit that we can get. I think this row is useful. We know where the 2, 7 are. What are the other 2 digits? They are the 3 and 6. This 6 tells us the order. The 6 has to go here, and that makes the 3 go there. So this is not a 6. In fact, we do have 2 6s looking up, and this 6 looks in. That places this 6. Okay, so there's a lot that we could do from this point. I'm going to come back to here and fill this triple. We know it's 1, 5, and there's another thing. It's the 4. Okay, so 1, 4, 5. We know this column is 1, 4, 5, 7. I think this can't be 4, so it's down to 1, 5, 7. Okay. Let's take a step back. What is the thing we most want to follow up on? Okay. So we got a bunch of these digits. Let's follow up on the stack here. We got these 2 4s, so 4 is in one of these 2. We got this 1, which doesn't seem to do much at the moment. Okay, we got the 3, also doesn't seem to do much. Okay, we got the 8. 8s are done. We got the 4. We did the 4, the 1, 3, 8. Okay. We also got these digits. There's nothing to do in this stack though. It's basically done. So what about this band? The 3, 6, 4, 8. Did we get anything from that? Yes, we have these 2 6s looking in. So 6 is in one of these 2. The 4 is marked. 8s are done. How about the 3? Yeah, we got the 3 marked. Okay. Just making sure I followed up on everything. So now I think the thing to focus on is if we have any rows, columns, or boxes down to 4 or fewer. I am noticing this row it's down to 2, 5, 6, 7. This cannot be the 6 or 7, so this is down to 2, 5 only. I think this can be any of 2, 5, 6, 7, unfortunately. Looking to see if this does anything. I don't think so. All right, and what's next? this row, let's relook at this row. We need the 1, 3, 4, 7. So this can't be the 1 or 3 or 4, right? We need 1, 3, 4, and 7 in this row, and this cell can't be 1, 3, or 4, so 7 is the only digit left. We call that a naked single because the only digit the cell can be is 7, so it must be 7. That cleans up this 7 here. Now, when I cleaned up that 7, I glanced up at the whole column to see how that affected 7s, and I saw that the 7 could only go here now. So for the column, we can place this 7. That's huge because it resolves all of these cells in the box. It also resolves this 2, 7 pair. It resolves this 1. This can't be 2 or 7 anymore, so it's only 6. Now 5 and 6 corner marks were removed. The 6 was already placed, but the 5 wasn't. It gets placed right here. And that places the 9 for the row. This is not a 9. That's not a 5. This is down to 1, 4. We can place that. This row has only one digit to place. As soon as you spot that, just place the digit, obviously. It's a 7. That resolves this 2, 7. This 6 resolves the 6, 9 down here that we got. This can't be 2 anymore. That places the 2, which places the 4. We get the 5 and the 3 here. We get the 5 and the 4. That's 5 and 3. And we're just finishing up now. The 5 in this box goes here. This is down to 1, 4 for the column, but it can't be 4. So that's the 1, 4, 1, 4, 1, 4. In here, we need the 3 and the something. 3 and 7. So this can't be 7. So that's 3, that's 7. And then over here, we need a 1, which goes here. We need a 3. And then up here, place the 3 and the 2 and the 9, and we're done. All right, so hopefully that was helpful. I know it collapses very quickly at the end there, but we found the important stuff, and it was pretty trivial from there. So I'm sure you could take over from there if you needed to. So yeah, we had some really cool stuff in this puzzle. We had we found these lined up 2s, which told us that one of these would be a 2. We had some pointing that was super useful, like the 1 and the 5 pointing over here. We had a couple instances of hidden pairs. We had a naked triple, which was very nice, and it's a kind of one of those irregular ones. This 3, 4, 5 naked triple. And you can see in our final solution, which is the only solution, the 3, 4, 5 triple ended up being 3, 4, and 5, right? The 2 ended up here. The 1 and the 5 ended up over here. So all of our markings were correct. We were doing a completely logical solve. All right, cool. Well, I hope you enjoyed this. And if you did, then why not leave a like, subscribe, and a kind comment below.